So now we know that a LED, or a light emitting diode, is a p-n junction under forward bias. The excess charge carriers created by that forward bias can then be used to generate photons. But we don't know, exactly how those photons are produced. So let's look at that mechanism. So we know that if we have an electron in the conduction band, it can go down to an empty state in the valence band. And that means, the conduction band's at a higher energy than the valence band. So that electron is losing energy. So where does that energy go? Well, one possibility is that energy can be radiated as a photon. So this is the process of recombination that we've learned before. But this recombination has a possibility of producing a photon. So what is the energy of this photon going to be equal to? Well, if the electron is at the lowest state of the conduction band, and it decays down to the highest energy level in the valence band, then we know that that photon energy is going to be exactly equal to the band gap energy. It's possible because the conduction band, is a range of states, a range of energy levels, that you have an electron at a higher energy level within the conduction band, and then it moves to an empty state at the top of the valence band. So in this case, a photon that's radiated from this is going to have some energy that's greater than the band gap energy. Not by much, but it still won't exactly be equal to the band gap energy. And I could have an electron at the edge of the conduction band fall down to an energy level that's below the top of the valence band. So again, this emitted photon will have a energy greater than the band gap energy. Or it can have a combination of these last two cases that will also end up with a photon that's greater than the band gap energy. So we don't have photons only being produced right at the band gap energy. There's photons with energies that are also, that vary a little bit from that band gap energy. So the point is that the light that's going to be produced by this process is going to have a certain bandwidth or a certain wavelength range associated with it. There are other mechanisms that physical mechanisms to produce photons in semiconductors, but this is the dominant one, and the most common, or the most dominant mechanism. And so we're not going to go in detail into those other mechanisms, but if you are interested in reading about those, then you should see section 14.4.1 in your textbook.